Priberam Machine Learning Webinar of the Year. Today we have here with us Wafaa. She's an LS PhD student at the University of Amsterdam. She's also here at the Starling Lab in Institute of Telecommunicações, and she's going to talk to us about her research, which focuses on context-aware machine translation. Thank you so much for coming, and I hope you enjoy.
Thank you, Leonor. Thank you, Priberam, for giving me the chance to present. So, hi, everyone. I hope you can hear me at the back. So I'm Wafaa. As Leonor said, I am a PhD student in Amsterdam, and I'm visiting Lisbon for a 6-month research visit. And today I'm going to talk about the research I've been doing for the past couple of months here in Lisbon. So I have been working on unlocking latent discourse translation in large language models through quality-aware decoding. I'll explain what I mean by discourse translation and the use of LLMs for machine translation and quality-aware decoding. And this work is under review. So my talk is going to start with introducing the problem, then our experimental setup, our results, and finally the conclusions. So we start by introducing the problem. What we studied is context-aware translation. And what we mean by context-aware translation is translating a source sentence to a target language given extra context. And the context here represents the previous sentences in the document that we are translating. So this is an example of a document from a TED Talk. And in this example, we are translating the sentence, it has a history of about 200 years into German. Why is this interesting? Because in German, when we are translating the pronoun it, we have 3 options. It's er, sie, and es, depending on the gender of the referent. In this case, it's American Sign Language, which is a feminine noun. So this is one phenomena that we observe in context-aware translation, which is pronoun resolution. So we studied several discourse phenomena in context-aware machine translation. The first one that I mentioned is pronoun resolution. It's for languages that have gendered pronouns. The translation should respect the gender of the referent. We studied other phenomena also, including lexical cohesion. So by lexical cohesion, we mean that if we have an entity translated multiple times across a document, it should be translated in the same way. We also studied formality for languages where there are linguistic indicators, such as pronouns that are used when you address someone formally. We also studied verb forms. So for some languages, the translation of the verb depends on the tone, the gender, the tense, the mood, and the cohesion of the document. I'm going to give examples of all of these phenomena so it's easier to understand what I'm talking about. So I'm going to give very simple examples of 2 sentences, and the entity where the phenomena is present is highlighted in yellow, and the supporting context is underlined. So in this example, this is translating English to German. It's similar to the one I presented earlier. We have the pronoun it, and the translation depends on the referent. In here, it's a masculine noun, amusement park. Lexical cohesion, for example, if we have a sentence, the reviewer gave us constructive feedback, we appreciate the reviewer's feedback. So the translation of the second mention of reviewer should be consistent with the first mention. For example, if we are translating into French, we have different forms for masculine and feminine translations of reviewer. So it should be consistent. For formality, the example here is in German. In German, when you translate the pronoun you, there are 2 possible translations, which are du or sie, depending on your relationship to the speaker, to the listener. And here it's friend, so it's du. For verb forms, this is Portuguese. So seen, the verb seen, I've been told it has 2 options, vista or visto, depending on the referent. And here it's Maria, so it's vista. So these are the 4 phenomena that we focused on context-aware translation. Then I'm going to move on to the experimental setup that we used. So first, I'll start with the models. Our main focus is to study context-aware translation in large language models because they prove to be strong contenders in machine translation. So we studied two models, which are Tower Instruct and EuroLLM. Tower is a fine-tuned version of fine-tuned from Llama on translation, and EuroLLM is pre-trained from scratch on multilingual data on all EU languages. I guess most of you know these two models. And we also included NLLB, which is an encoder-decoder model that's trained specifically for translation on parallel data. For data, we had 3 data sets. The first one is an English-Portuguese. It's Brazilian Portuguese specifically. It's a discourse-rich data set that's specifically curated for discourse phenomena in context-aware translation. It's a small data set, so we also wanted to expand the domains and language coverage and size. So included 2 more data sets, which are TED data and WMT24. In 6 languages: Portuguese, German, French, Korean, Arabic, and Russian. For the evaluation, we had different evaluation setups to test all of the things that we were interested in. The first thing is, of course, the overall translation performance using general translation metrics: BLO, COMET, COMET-QE. BLO is a lexical metric. COMET and COMET-QE are pre-trained metrics. COMET is a reference-based and COMET-QE is a reference-free metric. We also evaluated the discourse phenomena performance. So the way we do that is by automatically tagging words to the phenomena that I previously mentioned in the reference and in the output. And then we measure the accuracy of words in the output also being tagged in the reference. We also added LLM as a judge evaluation to further validate our findings. We used Prometheus model that's developed by Babel. It's a multilingual judge. We also included the small-scale human assessment to see whether the outputs align with human preferences. So now comes our approaches that we tested. The baseline translation method was greedy decoding. So we just select the hypothesis that maximizes the probability, which is the vanilla translation decoding technique, let's say. We also included a quality-aware decoding setup. Specifically, it was MBR decoding, which is minimum base risk decoding. It works by generating multiple hypotheses using any sampling method. And then, these are the set of hypotheses we generate, and then we select the one that maximizes a utility function. The utility function could be any choice of function. For our main experiments, we use the BLO, which is the lexical translation metric. Then we move on to the results. First, so here I'm presenting the results of the 3 models and the 2 decoding setups, the greedy and the QAD decoding, and I'm presenting the translation performance and the discourse phenomena performance. This is on English-Portuguese. So when we look at greedy results, we see that NLLB is outperforming the larger language models in the translation and discourse phenomena performance. But we observed that when applying QAD with the translation metric, we see great improvements in the translation and discourse phenomena performance, and we see that Tower Instruct is leading on almost all the metrics. So QAD does improve the translation and discourse phenomena performance of large language models. We also included the LLM as a judge evaluation to validate the findings. So in here, I'm presenting the difference between the QAD scores, that the LLM scores, I mean, and the greedy scores. We see that for LLMs, the Tower and EuroLLM, it's a positive difference. So QAD performs better than greedy. For NLLB, it's either the same or the QAD is even worse. So based on LLM as a judge evaluation, QAD improves the performance of large language models. Then for further analysis, we conducted a small-scale human study where we asked native and multilingual speakers to annotate 25 samples of TED data in all the languages. So we asked them to identify the discourse phenomena, whether it's present in a sentence or not, and whether it's translated correctly in the greedy output and in the quality-aware decoding output. By the way, they didn't know which one is greedy and which one is QAD. It was just like 1 and 2. We also asked them for the semantic difference between the two outputs to see whether QAD changes also in the semantic representations of our outputs. So it was a scale of 1 to 5, and for the general preference of the two outputs. Here I'm presenting the accuracy of the two outputs based on human annotations. It's averaged across languages, and I'm presenting all the phenomena. And we can also see that the QAD does improve the average accuracy across all phenomena and all languages. Then we wanted to study, okay, what happens with the meaning? Is QAD changing the semantics of our outputs or not? So I'm presenting here the preference against the semantic difference. For preference, we asked the annotators to annotate whether they prefer the QAD output, the greedy output, whether they are equally good or equally bad. And here, this is the semantic difference. 1 meaning that they are exactly the same meaning, and 5 means that they are completely different meanings. So we see that QAD outputs are in general preferred better across all semantic differences, and especially when the semantic difference is higher, we see that QAD outputs are preferred. So QAD generates semantically richer samples that align better with human preferences. Then you might ask, okay, is it only QAD with low metric that's the setup to improve discourse phenomena or not? So we performed an inference setup ablation to test the performance of other decoding methods or inference methods to the effect on them on discourse performance. So we experimented with QAD with different metrics, utility functions. We had BLOW, COMET, and CHRF, which are translation metrics. We also had LC ratio, which is the lexical cohesion ratio. It measures the number of repetitive tokens, the ratio of repeated tokens by the total number of tokens in a document. We also included Discourse score, which is a pre-trained metric based on BERT that measures the discourse coherence in a document based on sentence graphs. So you calculate the sentence graph of all the samples, and then you select the best one that maximizes the utility. We also included a different inference approach that was proposed by Nikos et al. At ACL. It's called fusion, and it works by so you generate multiple samples, and then you you fuse segments of different samples to generate new ones, and then you rank them based on a QE metric. So their approach is don't rank, combine. So it combines different segments. They use Comet QE as a QE metric. We also included an automatic post-editing setup. It's supposed to be simpler. So we get the translations using greedy decoding. Then we use XComet that can give us error annotations. I hope this is visible, I hope. That gives us error annotations of minor and major errors. Then we pass that to XTower that can give us explanations and corrections of the errors. So looking at results, we found that in general, the translation metrics performed the best. They had the best improvement over the greedy outputs. Discourse-specific metrics, lexical cohesion did not improve over the greedy output. Discourse score did improve, and it was comparable to the translation metrics, but it's extra expensive because it depends on getting sentence graphs for all the samples. Fusion and APE did not improve over the greedy outputs. So we wanted to look deeper into what are the changes that are happening with the quality-aware decoding in all of these setups. So we performed an edit rate analysis where we measured the percentage of all of the edit operations on the QAD outputs compared to greedy outputs. So these are like all shift, deletions, insertions, and substitute operations. And the numbers you see on top of the bars are the total edit rate. So we found that there is an optimal level of edits that's required for strong translation and discourse phenomena performance, which we can see with the translation metrics and also the Discourse score. Automatic post-editing results in fewer edits, but it does not improve the performance, and LC and Fusion results in more edits, but it also does not improve the performance. So in conclusion, we found that LLMs lag behind neural machine translation systems in discourse performance with greedy decoding. And we found that based on automatic metrics and human evaluation, quality-aware decoding improves translation and discourse performance of large language models. And among the examined method, QAD with translation metrics performed the best in discourse phenomena. For the next steps, we plan to use the annotated data, the human annotated data, as a reward signal to fine-tune the large language models to see if we can get even better improvements in discourse performance. And that's it, I guess. Was a short presentation.
So currently you're using online samples, and have you noticed any actual difference in the samples in respect to long, or it's just like the translation and that one kind of the chosen basically?
So we used 50 samples, and we know there wasn't necessarily that the samples were like some of them were too bad. We noticed that they are kind of comparable, but
So, for instance, out of those 50 samples, would you try to look each sample and see if they actually like solving this discourse phenomenon problems? Like some of them were okay, others were not, or it was mostly like completely different translation also?
no, if they were solving the discourse phenomenon because we did the discourse phenomenon evaluation. So yeah. You had a question?
On confusion matrix, you go.
Sure.
Yeah, so I don't quite get the axis on the left, the semantic difference. Shouldn't we always try to have the least possible semantic difference between the non-translated and the translated text? I don't know why. You said quality-aware decoding was good because you can see like that was on the right, but it shouldn't. But we also see that there's 11 on the 5 semantic difference. I don't understand. Is that good? I thought that was going to be bad because there should be no semantic difference between the original and translated text.
No, this is not between the original and translated. This is between the greedy outputs and the QAD outputs. So when the semantic difference is high, it means that the greedy output was kind of bad. Based on this thing, it means that the greedy output, it might be just a hallucinated output, and then QAD was a better output. It's a completely different meaning, but it's better.
Okay, so why there a greedy column as well? I think this will confusion a bit.
Oh, okay, I can try to explain it again. Sure. So we asked the human annotators to annotate two things. The first thing was the semantic difference between the two outputs, because we presented them with greedy output and QAD output. So we were asking them, is it the same meaning or not? We wanted to see whether the quality-aware decoding leads to only just changes in it's the rephrasing, but it's still the same meaning. That's the semantic difference. And then we asked them generally, which one do you prefer? Do you prefer output 1, output 2, or are they equally bad or equally good? So you see these two axes being presented here. When the first one is looking at the preference, in general, QAD is preferred. Looking at the semantic difference, we see that QAD is preferred better moving, like when the semantic difference increases,
Oh, okay.
QAD is
So
preferred
the
better.
difference is like the text itself, not what they are deciding on. Is that it? Like I still don't understand what you are asking the images to understand here.
I want them to tell me whether the two outputs are the same meaning, but just a rephrasing, or whether there is a total difference in meaning, because that will help us to detect whether the greedy output was a hallucination or whether also the QAD output is a different output.
So, but you gave them like the actual text as well, right?
The source, yeah, we gave them the source. Of course.
Any more questions?
I have a question. So I guess in these experiments, you are so you feed the entire paragraph into the model. So
No,
the context is not provided at once.
it's provided, but we ask it to translate the sentence. So it's kind of a sentence translation with an extra context. Like the way we prompt the models is we give them, depending, there is different formats, but we give them the context and then we explicitly say, this is, for example, parallel sentences from the document, then translate this current sentence.
This is the same for the medium from the reading.
Yeah.
They just differ on the way they decode.
Exactly.
And the hypotheses that they try are just the final sentence that they are translating. Just the sentence.
Yes.
Do they have a condition on any? So they don't even try to translate the context, right?
Yeah, we give them the context and the source and target context.
So how do you know that you mentioned lexical cohesion as one of the phenomena that you are acting? But if you are not translating the context, how can you measure lexical cohesion?
With lexical cohesion, if we have a sent token in the target that has been mentioned in the context, I expect my model to translate it in the same way that it was in the context.
But you are not.
Yeah, I'm translating the current sentence, but so I'm actually making it easier for the model. I'm giving it the gold context.
Is the target context machine translated or is it?
It's gold.
It's gold.
Yeah. Like in this setup, I give it the sentence, we appreciate the reviewer's feedback. Actually, I gave it, we have English sentence, the reviewer gave us constructive feedback. French sentence is this translation. And then I ask it, given the context, translate this one. And then I see whether it respects it or not.
So you're basically the model is coherent with the gold translation.
Yes.
So I have another question. There is no more questions. Which is you had a plot with the edits, number of edits. I guess I understand what edits mean if you are doing automatic posterity, but for the other models, you are doing looking at the difference between the greedy and the other methods. Is that it?
Yeah, it's all of these are the difference between the greedy and the final output, basically.
Okay. Which is not really edits, but you are still measuring those different.
Yeah.
So
sure.
because we point about this as well with the quality decoding at sentence level or short paragraph level, but we need to look very deeply at this discourse. So you're one of the things to suggest that will be specifically strong when you care about this discourse. Is that true?
Yes.
I have a question. How do you select the hypothesis? Because you are looking for the glue score, but you have to have the ground truth.
Yeah. So MBR works by you take each one of the samples and you consider it as your pseudo reference, and then you compare it to all the others, basically. So all the samples act as references, and you compare them to all the others.
It's within the sample.
Yes.
Oh, thank you.
Sure.
But for the glue, compare the glue score within the decoding samples you obtain.
Mhm.
That and how do you select the one that is most common between all of them?
Yeah, so you get the average low score of each sample compared to all of the others, and the one that has the highest average is the one that you select.
Okay.
Okay, so then let's thank the speaker again and see you next year.